Section 7.5. Finally, we got to the last operation called division of what? Of radicals. When it comes to division, we have three cases. Here is case one, when the denominator contains one square root term, only one, such as 1 over square root of 5, x over square root of 6, y over square root of x, or square root of x over 2y, which you can write this as the square root of x over square root of 2y. You still have one square root term in the denominator. So let's do case one problems. The question is divide the following. Remember, divide radicals means eliminate the radical term from the denominator. The denominator. Get rid of the radical from the denominator. That's what the objective of division is. Sometimes it is also known as rationalize the denominator. Rationalize the denominator. That's the terminology sometimes people use. To rationalize the denominator of a fraction, that means get rid of the radical sign, or radical term, I should say, from the denominator. So what do you do for these kind of problems? Basically, you just multiply top and bottom by the bottom. So multiply top and bottom by the bottom. Okay, why? Because this gives you square root of 5 on top, square root of 25 at the bottom, but square root of 25 is 5. We are done with division of radical. Yes, it is as easy as it sounds. All we have to do is what? Multiply top and bottom of the fraction by the denominator. What about this guy? Multiply top and bottom by square root of 6. On top, you get x square root of 6. At the bottom, you get square root of 36. But the final answer is x square root of 6 over 6. Final answer. Can I cancel the 6's here? No. This guy is under the radical. This guy is not. What about y divided by square root of x? Same thing. You multiply top and bottom by the denominator. So you get y square root of x over square root of x squared, but square root of x squared is x, so you get y square root of x divided by x. What if I have a fraction under the radical? First you split the fraction, then divide. Remember, the objective is to eliminate the radical term from denominator, yes? So what you do, you multiply top and bottom by the denominator. So here, on top, you multiply x by 2y, so you get 2xy. Here you get square root of 4y squared. But the square root of 4y squared, you and I, we both know is 2y. So the answer is the square root of 2xy divided by 2y. Anytime you multiply a radical by itself, the radicand pops out of the radical sign. Do you see it? This is the square root of 7xy to the 4, what? Over 2z. So the first thing you do, you split the radical, like so. Then you multiply top and bottom by the denominator, like so. Do you see it? Remember, in the denominator, you should get the radicand. But on top, you're going to multiply these radicals because they have same indices. So you get 14xy to the 4z. But mayday, mayday, we have a problem. The problem is the index is smaller than the power of the y. So this has to be simplified. How? That would be the same as what? 2 divides into 4 twice. Guess what? Y squared pops out of the radical on top. And 14 and x as z stay under the radical. and the 2z at the bottom. So this would be the final answer. Because sometimes dividing is not enough. You also have to simplify the final answer by, what we learned, how to simplify radicals. Case 2. What if the denominator contains one radical, but with an index other than 2, like cube root, fourth root, and so on and so forth? So how would you do these kind of problems? Well, for these kind of problems, you just have to be creative and multiply top and bottom by what you need. What do I mean? What do I mean by what I need? Well, the power of 4 is, as a matter of fact, I can write 4 as 2 squared, correct? So let me just erase this quickly. I can write 4 as 2 what? Squared. Wouldn't it be nice if the power of 2 was 3? So I would get 2 to the power of 3, which is 8. Cube root of 8 would be 2. So what I need is one more 2. So I'm going to multiply top and bottom by what I need to make this guy a perfect cube. So cube root of 4, I don't know what that is. But the minute I multiply 4 by 2, of course, in this case, cube root of 2, then I get in the denominator, I get what? Cube root of 4 times 2, which is 8. But cube root of 8, I know it's 2. But then this guy just goes for the right, so the final answer is cube root of 2 over 2. And that's how you rationalize the denominators when the denominator contains one radical with an index other than 2. What about this guy? What do I multiply? Well, you multiply top and bottom by the fourth root of something. Wouldn't it be nice if this power of 2 was 4? So 4 would be divisible by 4. So what do I need? I think I need 2 more x's. So you multiply top and bottom by what you need. Okay, so in the denominator, I get fourth root of x to the 4 because x squared times x squared is x to the 4. On top, I got what? Fourth x squared. But fourth root of x to the 4 is x. Why? 4 goes into 4 once, so x pops right out. So on top, you get fourth root of x squared divided by x. The minute that radical sign disappears from the denominator, that would be the end of the problem. This is cube root of what? 10 divided by x squared, so split this fraction. Okay. Once again, wouldn't it be nice if this guy was x cubed, so I can take its cube root, so it looks like I need one more x to pull that guy out. When I say one more x, I mean I have to multiply top and bottom by cube root of x. So what do I get in the bottom? At the bottom, I get cube root of x cubed. Is that right? Let me just erase this. Cube root of x cubed. On top, I get cube root of 10 times x. Is that right? But cube root of x cubed is x, so mission accomplished. Why? What was the purpose of this section? Is to eliminate the radicals from the denominators, and we have 3 cases. This is case 2. What about this guy? Fifth root of x to the 4. Wouldn't it be nice if this 4 was 5? So I need one more x. So I multiply top and bottom by fifth root of x. Notice index doesn't change. It's still the same as what it was at the bottom. So this would be the same as 23 fifth root of x over fifth root of x to the 5th. X to the 4 times x to the 1st is x to the 5th. But 5 divides into 5 once, so x to the 1st pops out. So the answer is 23rd, 3 fifth root of x divided by x. There's no need to show the what? First power. That would be like redundant. cube root of 3 over 2x squared, same as before. So this is cube root of 3 divided by cube root of 2x squared. I like this guy to be perfect what? Cube. The closest number to 2 which has a perfect cube is 8. So I need to multiply top and bottom by what? 4 to make this guy 8. And x squared doesn't have a cube unless its power matches the index, so I need one more x. So I need to multiply top and bottom by cube root of 4x. Do you see that you multiply top and bottom by what you need? In other words, you have to be creative. You got to create this factor. Okay, there is really not a set rule. You just have to look at the problem and see what does it take to what? Liberate this guy from the denominator. You know, the radical sign. You know, liberate the denominator for having a radical in it. Anyways, the top is what? Cube root of 3 times 4x is 12x. But remember, the denominator right now is 2x squared times 4x, which is what? 8x cubed. But cube root of 8x cubed is what? 2x. And we have reached the final answer, which is cube root of square root of 12x divided by 2x. Same thing goes here. This is 4th root of 2x cubed over 4th root of 4y squared. The closest number that I know has a 4th root is 16, correct? So I'm going to multiply top and bottom by 4th root of 4 to make this guy 16, because 4th root of 16 is what? 2. And I like to convert this or force this power to look like 4, so I need to move 2 more 2's. So this is what you have to multiply top and bottom by. Whatever you multiply bottom, you got to multiply the top by the same factor. Otherwise, you change the problem. So now the problem changes into 4th root of 2x cubed times 4y squared, which is 8x cubed y squared. Is that right? Over 4th root of 4y squared times 4y squared is 16y to the 4th. But remember, 4th root of 16 is 2. Why? Because 2 times itself 4 times gives you 16. So therefore, the answer at the bottom is what? 2. And 4 goes into 4 once, so y pops out of the radical sign. So the final answer is 4th root of 8x cubed y squared divided by what? 2y. Final answer. Finally, we got case 3. Case 3 is when the denominator contains 2 terms, which where one of which or both are square roots. In other words, either you have one square root plus a number or a minus a number. Let's say this guy is x. Or you have 2 square roots, okay? Either you have a square root and a number, or 2 square roots, square root and a number, or 2 square roots. In this case, what we have to multiply top and bottom is by what is known as conjugate. What is conjugate? A minus B is said to be the conjugate of A plus B. Why? Because A minus B times A plus B gives you A squared B squared. Remember the difference of 2 squares? Remember how did we factor A squared minus B squared? That was A minus B plus times A plus B. So these guys are called conjugate of one another. So the conjugate of square root of 3 plus 1 is square root of 3 minus 1. Do you see it? The conjugate, that's Conjug what? ATE, conjugate. The conjugate of the square root of 7 minus 1 is the square root of 7 plus 1. The conjugate of 2 square root of 5 minus the square root of 6 is 2 square root of 5 plus the square root of 6. The conjugate of the square root of what? X plus 2 minus 3 is the square root of x plus 2 plus 3. So when you have case 3, you multiply top and bottom by the conjugate of denominator. In this case, the conjugate of square root of 3 plus 1 is the square root of 3 minus 1. That's what you multiply top and bottom by. So what do we get? Here you get what? 5 square root of 3. Let's just not multiply for a minute. Let's just hold on to 5 and see what shows up in the denominator. The denominator is the square root of 3 times the square root of 3, which is square root of 9. 1 minus the square root of 3, then you got positive square root of 3. 1 times negative 1 is negative 1. These guys always cancel, and you should have no radical in the denominator. Square root of 9, you and I, we both know is 3. Don't forget you got a negative 1 here. So that's 5 times square root of 3 minus 1. The minute you multiply top and bottom by the conjugate, the denominator, the radical sign disappears from the denominator. If you still have a radical, something went wrong, right? Okay, 3 minus 1 is 2. So the final answer is 5 the square root of 3, if you distribute, minus 5 divided by 2. Final answer. Remember, the purpose of dividing radicals is to eliminate the radical from the denominator, correct? And I did that, so I'm done. Not much left to do. Here, the conjugate of the square root of x minus 1 is the square root of x plus 1. So multiply top and bottom by the conjugate of the denominator. Remember what conjugate is. Multiply the tops, so hold on to the 4, just put it in product form. The denominator is what? Square root of x squared if you FOIL it. What? Plus the square root of x minus the square root of x minus 1. Once again, the middle terms should cancel. Square root of x squared is x. So all you get is x minus 1 in denominator, and on top you get 4 square root of x plus 4. And that should do it for that problem. Do you see it? The minute the denominator has what? Is free of radical, you are done. That mission accomplished. What about this guy? You multiply top and bottom by what? Conjugate, which is 2 square root of 5 plus the square root of 6. Okay, so on top you get a square root of 5, 2 square root of 5 plus square root of 6. At the bottom, you got to FOIL this, so you get what? 4 square root of 25 plus what? 2 square root of what? 5 times 6, 30. Negative square root of 6 times 2 square root of 6 is 2 square root of 5 is negative 2 square root of 30. Negative square root of 6 times positive square root of 6 is negative square root of 36. These guys, as usual, they should cancel each other out. And at the end of the day, you should have what? No radical in the denominator. So square root of 25 is 5. Square root of 36 is 6. That's 4 times 5 is 20 minus 6. Right? But now you distribute the square root of 5 by these two terms. You get 2 square root of 25. And then plus square root of 30, 5 times 6. 20 minus 6, I believe it's what? 14, is it? And then 2, what? Square root of 25 plus square root of 30. Can I wipe out the 2 with 14? No, the plus sign won't let you, right? If you had a multiplication, yes, you could cancel. But the plus sign won't let you to what? Cancel the 2 and 14. Finally, you got 4 over square root of x plus 2 minus 3. The conjugate is the square root of x plus 2 plus 3. Notice I'm not changing the signs of under the radical. I'm changing the sign of this guy to opposite of what it was. So on top, I get 4 times the square root of x plus 2 plus 3. At the bottom, what you get, here's a shortcut. Remember we said a minus b times a plus b is always a squared minus b squared. Remember the difference of two squares? Remember this is like a minus b times a plus b. So to square this guy, remember your final answer should look like this. A squared minus b squared in the denominator. Square of this, what? Wipes out the radical sign. Minus square of 3 is 9. Notice that way you can avoid the foiling. So you can get the answer immediately if you remember this formula. When you multiply at two terms by its conjugate, you always get a squared minus b squared. In this case, suppose this is a, suppose this is b, suppose this is a, and that's b. So this is a minus b times a plus b. The answer should be a squared minus b squared. In other words, the denominator should be the square when you raise this guy to the power of 2. Remember, when you square a square root, the square wipes out the radical, you get x plus 2. And when you square the 3, you get 9. So the denominator will be x plus 2 minus 9, which is x minus 7. And the top would be 4 square root of x plus 2, then 4 times 3 is 12. Final answer. Do you all see it? Finally, we got this problem. They want you to combine these three terms. First, you have to rationalize this. So what you have to do, you have to, for the first guy, multiply top and bottom by the bottom. Oops, sorry. So that would be like case 1. The denominator contains 1 square root, so multiply top and bottom by the bottom. This guy is the same as case 1, except first you have to split this. Then you have to multiply top and bottom by the bottom. And the last guy, the square root is on top, no problem. So there's no need to rationalize this. So this guy becomes 3 square root of x over x. Okay. Square root of 9 is 3, so that would be 3 square root of x. Square root of x times square root of x is x. And then you got what? Positive 2 square root of x over 1. Is that right? Over 1. So now these guys have the same denominators, so I can just add the tops, which is 6 square root of x over x plus 2 square root of x over 1. But now I need LCD, which is x. So this is 6 square root of x. You multiply top and bottom of this fraction by x, you get 2x square root of x. Final answer. And that's pretty much how you divide. So you got 3 cases. Make sure you review this video and make sure you'll know how to divide radicals. Thank you.